Chapter 9 Differential Calculus Limits and Continuity. Example 9.3 Evaluate limit x tends to 2 minus greatest integer function x and limit x tends to 2 plus greatest integer function x. Solution. The definition of a greatest integer function x is equal to n, where x lies between n and less than n plus 1. Our x lies between n and n plus 1. Here less than or is equal to, here strictly less than. So our question is, so evaluate limit x tends to 2 minus greatest integer function x and limit x tends to 2 plus greatest integer function x. So do the question, do the division 1, limit x tends to 2 minus the greatest integer function x is equal to, so put one reference table, x, the greatest integer function x, 2 minus, that is left of 2, so 1 less than or is equal to x less than 2. By the definition, this greatest integer function x takes 1. Therefore, clearly this value is equal to 1 and limit x tends to 2 plus the greatest integer function x is equal to. So, draw one more table, x, greatest integer function x. So, 2 plus means 2 plus. So 2 plus means right of 2. It is 2 less than or is equal to x less than 3. So this greatest integer function x takes 2. Therefore value of this is 2. The number 1, number 2 are calculated. Therefore question number 9.3 over. Question number 9.3 over. So we move to example 9.4. The question is f of x is equal to x plus 1, where x is greater than 0, x minus 1, x is less than 0. Also verify the existence. Verify the existence of limit x, limit as x tends to 0. The question is f of x is equal to x plus 1, x greater than 0, x minus 1, x less than 0. Verify the existence of a limit as x tends to 0. First draw the graph. For this question. Draw the graph for this question. So y-axis and x-axis. This is x-axis, this as a y-axis. So for x greater than 0, put one table, x greater than 0. X greater than 0 means, here x plus 1, this is 0. X greater than 0 means the 0 is not included, then 0.1, 0.2, all are included. 0 is not included. All the other points 0.1, 0.2, all included. So first take 1 and 2 and 3 and going. So left of 1, 0.9, 0.8 and 0 is not included. So for the number 1, so 1 plus 1 as a 2. For the number 2 is 3 and 4 and so on. Just plot the points on the graph. So here 1, 2, 3 and 4. In the left side, -1, -2, -3, and y-axis +1, +2, +3, and +4. Here -1, -2, and -3. So for the number 1, 1, 2, the point is there, 1, 2, and 2, 3 here, and 3, 4, the point is there, 3, 4, 3, 4, and left of 1, there is 0.9, 0.8, the point is, so our values lies there, that is reaches to the value is very closer to this 1. So here 2, then the value is very closer to 1, very closer to 1. Therefore, the value is very closer to 1 but not takes 1. Therefore, draw the line through these points. The line is like here the 1 not included. The 1 is not included. This is a f of x is equal to x plus 1. And for the value x lesser 0, so put one more table. So one more table, x lesser 0. X lesser 0, x minus 1. Our f of x is a x minus 1. Less than 0, it is minus 1, minus 2, minus 3. So minus 1, minus 2, minus 3 and going. So in front of minus 1, here minus of 0.9, minus of 0.8 also there. And minus 1, substitute here minus 2, minus 3, minus 4 and so on. Plot these points on the graph. So minus 1 takes minus 2 and minus 2 takes minus 3 and minus 3 takes minus 4. Here minus 4 and so on. And left of minus 1, the right of minus 1, so left of 0. Right of minus 1, left of 0 takes values, all are very closer to minus 1. So very closer to minus 1 but not takes minus 1. So draw the line through these points. We get the graph is like, the graph is moving here. Minus 1 is not included. This is f of x is equal to x minus 1. This is the graph for the given question. So now our aim is to check the existence of a limit as x tends to 0. First do the calculation for left limit. So limit x tends to 0 minus f of x is equal to limit x tends to 0 minus, so left of 0, f of x takes x minus 1. Here write x minus 1. Substitute 0 in the place of x, we get minus 1. And do the calculation for right limit. X tends to 0 plus f of x. This is equal to limit x tends to 0 plus, that is x greater than 0, our f of x is x plus 1. So substitute here x plus 1. So here substitute the 0 for the place of x, we get 1. This note that this is a number 1 and this is number 2. Comparing 1 and 2, they are not same. So from 1 and 2, 1 and 2, surely we can say that so limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus f of x. Therefore the limit not equal means the limit doesn't exist. Therefore limit x tends to 0, f of x does not exist. Therefore example number 9.4 over. Thank you.